In this question, 3-point electric charges are placed at the vertices of an equilateral triangle. Then capital Q charge is placed at the centroid of this triangle. Here we have to find out sign and the magnitude of this capital Q charge. The given condition is the small q charges are in equilibrium. Here, three vertices charges are in equal sign and magnitude. So, the force experienced by these charges are equal. So that we consider only one vertex, that is A vertex charge. This A vertex charge experienced force by B vertex charge and C vertex charge. First, we calculate force experienced A weighted charge by B weighted charge. Let us consider that force vector is F1 vector. According to Coulomb's law, we calculate F1 vector. F1 vector is equal to K into Q square by L square, where Q1 and Q2 is equal to plus Q charge. Similarly, we calculate force experienced on A weighted charge by C weighted charge. Let us consider that force vector is F2 vector. So, F2 vector is also KQ square by L square. Next, we have to add this two vectors F1 and F2 vectors according to parallelogram addition vector. For this, we use this formula, that is resultant F vector is equal to square root of A square plus B square plus 2AB cos theta, where A is the value of F1 vector and B is the value of F2 vector. For this, we need to find out this theta value. Here, BAC value is, that is theta value is, angle is 60 degree. So that this angle is also 60 degree because vertically opposite angles are equal. Substituting A, B and theta value, we get this one. Cos 60 is 1 by 2. Cancelling this 2 and 2, we get this one. Simplifying this 2 value as k q square by L square whole square. Now we have three same values. Adding these values, we get square root of 3 into k q square by L square whole square. Taking square root for this value, we get root 3 into k q square by L square. Then we find out AO distance. O is the centroid, AD is the median. In an equilateral triangle, this centroid divides this median in a ratio 2:1. To find out AO distance, first we need to find out AD distance. Using trigonometric ratio, we calculate AD distance. Sin theta is equal to opposite side by hypotenuse. Opposite side is AD value and the hypotenuse is L. Theta value is 60 degree. Sin 60 value is root 3 by 2. So that we get AD is equal to root 3 by 2 into L. And AO is equal to 2 by 3 into AD. Substituting AD value here, we get this one. Cancelling this 2, we get root 3 by 3 into L. This 3 we can return as root 3 into root 3. Cancelling this root 3, we get 1 by root 3 into L. Now we have AO distance, so that we calculate A vertex charge experiencing force due to capital Q charge. Let us consider that force vector is F3 vector. According to Coulomb's law, F3 vector is equal to K into capital Q small q by 1 by root 3 L whole square. Expanding this value, that is root 3 whole square value is 3, and reciprocaling this value, we get this one. Already we have resultant vector. In the question itself, it is given the 3 point charges are in equilibrium, so that we consider this F3 vector plus resultant F vector is equal to 0. So bringing this F3 vector to the right hand side, we get this one. Substituting this resultant vector and F3 vector in this equation, cancelling k, q, small q, L square values, we get root 3 into q is equal to minus 3q. Bringing this 3 to the left hand side and changing 3 as root 3 into root 3, cancelling root 3 and both the numerator and denominator, we get q by root 3 is equal to minus q. Multiplying this by negative sign, we get q by that is minus q by root 3 is equal to q. So that we get sign of this capital Q charge, that is negative sign. Magnitude of Q charge, capital Q charge is small q by root 3. This is the answer.